Hello, this is Dr. Kraus, and I want to address a few hang-ups that I've been seeing, especially on exam 2 for our class this summer, regarding Sympy. I'm going to call these tips and gotchas. So I want to address these 4 things that I think are the biggest Sympy-specific problems that I'm seeing. How to understand Sympy.py versus NumPy.py. I guess along with that, do you understand that Sympy is expecting radians? The dot simplify function or method behaves differently for matrices versus scalars, and that caused some issues. Declaring your symbols ahead of time is really important. That was really only one person, but I want to make sure that everyone understands why it works. I did see some other people having issues with trying to declare just one symbol, and so I want to talk about that as well. So let's start with pi. So if you, I think I've mentioned this, that sometimes mixing NumPy and SymPy in the same notebook requires additional care, or it can cause problems. So if I have, and part of that has to do with namespaces, which we haven't really gotten into and is a little bit outside the scope of what we're doing. So 2 things happen. If I do import NumPy as MP, I then have an np.py, which would be a floating point number. If I also have this line from NumPy import pi, then pi without anything in front of it refers to the numpy.py, which refers to a floating point number. And then if I just have this, if I want to get at, so here's what I'm saying. Pi just by itself is a floating point number. np.py refers to that same thing and is also a floating point number. But if we're using SymPy, and if we want to get exactly 0 or exactly 1 for the sine or cosine of, say, 90 degrees, or pi over 2, then we need to use sympy.py, which you can see refers to a Greek letter, and it has special meaning in the SymPy module. Additionally, sympy.sign expects radians. So I see kind of a lot of this on exams. If you say sympy.sign of 90, it assumes that you mean the sine of 90 radians. And so it just leaves that as sine 90 because it doesn't want to return some really long floating point number. Sympy is trying to avoid floating point errors and that kind of thing. If you use the sympy.n function to force it to give you a number, it's like, okay, here you go. This is the floating point number that corresponds to 90 radians, which is exactly the same as np.sine of 90. So that is not what we want. Additionally, if I use pi over 2, this pi without anything in front of it is the numpy pi, so it's a floating point number. That sort of looks okay, but this 0.0 should kind of tip you off that something isn't exactly as you would like it to be. And so the correct answer for all of this really is sympy.py divided by 2 gives me exactly 1 as a floating point number. If I was just going to do something live here that would potentially screw up my recording, I assume that if I change this to cosine, right, so now you see the real issue of floating point numbers are bad. Where this has no decimal point on it, that's an integer value. And so one of the things I've done in my code is repeatedly define P90 and N90 as a positive 90 in radians as a symbol, and N90, so that if I take the sympy dot cosine, for example, of P90, I will get exactly 0 and not this floating point confusion. And you've already seen when I do the sine one up here. Well, I guess I can do it just to verify that it actually works. Exactly 1 and exactly 0. So these are your friends when it comes to using alphas of plus or minus 90 degrees in SymPy. So that is issue number 1. Issue number 2 is that the dot simplify method confuses some people, and it led to some people having determinants that were actually right, but they weren't looking at the simplified version because of this kind of weird gotcha. And so this is kind of a mess. For example, if I have some vector quantity and I call its simplify method, it actually does the simplification on each element of the vector, but it actually returns nothing, or specifically returns the Python value of none, which is a special value that we haven't talked a lot about. So if I tried to capture the answer of v33.simplify, it actually is nothing. But then once I've called the simplify method, v33 itself has been modified. So I think the kind of right way to do this in the code, if you wanted to do it all in one step, would be to call the .simplify method and then immediately print out the variable itself. And many of you did that in this situation, and that works great, and it does what you kind of expect it to do. Although I did see one person who tried to kind of capture the result of the .simplify and then was really confused as to why. For example, if I did this, I would now overwrite the value of v33 itself, and now the rest of my calculations are screwed up. So we don't want to do that. I'm going to change this back for my instructional purposes. I got to go back through and do those things again. So for a matrix or a vector, calling .simplify and then printing back out the variable itself is the right way to go. The opposite is true when it comes to scalars. So if I have some super long Jacobian thing and I take its determinant and I think, oh, that's terrible, how am I supposed to understand that? A lot of you did this. I'm going to simplify it, and then I'm going to print it out, because this is exactly what you do that's correct for matrices. But what's weird about this is because it's a scalar, simplify doesn't change the value of jdet itself. So when you go to print out jdet, you actually get the original one. In this case, simplify, rather than modifying the variable, does in fact return a new expression that is the simplified version. So if I needed to capture that for some reason, I would then put my answer equals the result of the simplification, print out the answer, and that's correct. So this approach for a scalar leads to confusion, and you're not actually seeing the simplification. And so what you actually want is that, or just to print the simplify itself. And so I think if you're on an exam or a quiz and you're just not sure what the right answer is, and you're kind of freaking out by some of this, understandably with time pressure and that kind of thing, just do the .simplify and see if it prints anything. If it does print something, that's probably your simplified, that should be your simplified answer, not probably. If .simplify prints something, you have a scalar expression, and that's the right answer. If, on the other hand, you came up here and called .simplify and it printed nothing, then you know, okay, I need to look back at the variable itself. And so that's a weird quirk. I didn't really realize that until I saw it happening to some students on the exam. Simplify is different for matrices and scalars, and if you're not sure which you're looking at, just try running the simplify in a cell by itself and see if it prints something. If it does print something, then that is your answer. If it doesn't print anything, then you need to reprint the matrix that you were trying to simplify. Okay, last two topics related to declaring symbols. One weird thing that I actually didn't know worked that caused some confusion for at least one student is that you can kind of get away with not pre-declaring your symbols, but it's going to come back to bite you really bad in the end. So this mostly works because Sympy does allow you, for example, to take the sign of a string, and it just kind of returns a nice looking version of that. Or you can make matrices out of strings, and so it works. But because of how this code that does the .dh matrix for robotics Sympy works, this you cannot just have a string here. And the reason for that is Sympy is happy to take the sign of a string and turn that into a variable, but then you're trying to multiply it by a string that hasn't had anything called on it, and so it's just a string. Sympy hasn't converted it to any kind of symbol. And so you get this weird, kind of hard to understand, can't multiply a sequence by non-int of type mul thing, and you're like, what are you talking about? Understandably. So the string is a sequence, and sign of alpha is the mul that you're, I don't know, whatever. So basically the D is the only thing that has to multiply something else but doesn't have a sine or cosine on it. And so it's this operation that is not allowed if D is a string. So all that to say, yeah, you kind of get away with it. Yeah, it saves you a step, but in the end, it is really dangerous to operate directly on strings. Strongly, strongly, strongly encourage you to always use the Sympy.symbols to pre-declare any symbolic variables. And now when I go to take the DH matrix, everything just works. Okay, the final gotcha is if I'm declaring just one symbol, and I saw a student do this on the exam, and I think I've made this mistake myself, is that if I want to declare just one variable, you might think that since we normally put them in a list, I'm going to put it in a list of just one thing. And it behaves just a little weird when you do that. And so now theta 2 is itself a list, not the variable inside the list, which really isn't what you want. So if you're ever in this situation with just one variable, just get rid of the square brackets. So this will actually do exactly what you want. So hopefully those things are helpful, and if any of those 4 things were tripping you up on exam 2, hopefully you know how to handle them correctly for the final exam. Thanks.